Okay, hello students. I hope everybody is doing fine. Today, let's talk about a topic that is work and energy. Okay, so I'm sure you all have had your food and you are feeling energized to do a little bit of work. Okay, so let's see whether you have done any work or not after the end of this, topic. Okay, so let's begin. So, what exactly work is? In physics, if you are sitting, okay, here, if I'm sitting and if I'm not moving, okay, I'm just talking and talking all the time and, teaching you about this, concept. If I'll say I have done a lot of work, maybe I'm sitting here for 3 hours and I, go back and I say, everybody, I have done a lot of work today. I was sitting there for 3 hours. Physics would say that you haven't done any work because you have not moved at all. Okay, what do we mean by that? That work is said to be under physics. Work is said to be done when a force is applied on an object, and the object is displaced in the direction of the force. Right? So, for example, if a force is applied on this box, okay, so I'm applying force in this direction, and in this direction only the object moves. Okay, so then it is said to be have that the work has been done. Okay, so here in physics, firstly we need to know 2 to 3 things, which I'll just tell you now. So first is force. So force is represented by F. Okay, and force must be applied on the object, then only we can talk about work. Then there must be a displacement. Okay, so F into D, and also add some angle. So angle here is theta. Okay, so the angle between the force and the displacement actually matters, because I'll tell you why. If there is no angle, the angle is 0 degrees. Okay, then there will be work done. But if you're applying force on an object on, let's say, this side, okay, and it moves upward, that is perpendicular to the force applied, then there won't be any work done. I'll tell you how and why that works. Okay, so let's move forward with these 3 terms which we have got to know. Okay, so when work is actually done, let's talk about that. So a force must be acting on an object, right? So you should be pushing, like here you are pushing the car. So you're pushing it in a direction, okay, maybe from forward or maybe from backward. So that should be there. Then the object should move from its original position. There should be a movement. If I'm sitting here and talking, that is not work, because I'm not moving. I'm not displacing from one place to another. I'm not being displaced. Okay, and force component in the direction of motion. At least some component of the force must be in the direction as the displacement. So suppose if we are pushing the car and car is moving in, this direction or some other direction it goes, okay, this way or this way. So that won't be work done in perpendicular direction. Obviously it can't go in perpendicular direction, but let's just say, okay, so I'll again like discuss that later. So work is done when you're pushing a car and it moves forward. So if you are pushing it in this direction and it moves here, then there is work done. No work done is when you are holding a suitcase and standing for, in a queue maybe for 10 hours. That can be work done in a very, common situation, but physics won't justify it. Okay, you can't justify it too, physicists. Okay, now the formula of the work would be, so here, okay, let's just, yeah, so there is work, right, work done, and you measure it in joules. Okay, so work done is equals to the force applied or magnitude of force into displacement and cos theta. Okay, theta would be the angle between the force you have applied and the displacement where it occurred. Okay, so if you have applied like this and the movement is in this direction, there is movement, the theta is, the angle is 0. There is no angle such as like this. Okay, so no angle is there, so it is 0, and cos 0, you can remember, sorry, cos 0 degree is equal to nothing but 1. Okay, so work done could be equal to F into D, that is force into displacement, into cos theta. The value of cos theta or cos 0 degree is 1, right? So FD is work done. Okay, I hope this is clear. Okay, because you are, dealing with trigonometry in your mathematics, you will be dealing it with soon. So you'll be able to understand that in a better way. But for now, you can remember that cos 0 degree is 1 and cos 90 degree is 0. Okay, so I'll tell you how it works later. Now, positive and negative work. So work can be positive and negative as well. Let's see how it is. So positive work will be when you are putting a force, okay, when the force and displacements are in the same direction. Okay, so for example, horse pulling a cart. So horse is pulling, this cart is there, let's say the cart is there, right? And horse is pulling it. Okay, this is not a very good example, but let's just imagine horse is pulling it in this direction. Okay, so the direction of the force and displacement is same. Lifting a bucket upward. So you are putting the force upward and the displacement of the bucket is also upward, right? So again, that is a positive work. And pushing a box forward. So you pushed a box forward like we were discussing in previous examples. So again, this is, a positive work. Now let's talk about the negative. So when force and displacement are in opposite direction. For example, friction while sliding a box. So when a box is sliding, the rough surface is providing a frictional force against the box. Okay, and that is in opposite direction. That means you are putting force this side, but you are getting, the displacement is this side, but there is a negative force or a frictional force on the opposite side. So that is a negative work done. A person lowering a bucket slowly. Okay, so that is also lowering the bucket slowly. So that is also a, you can say, opposite force. And breaking a cycle. So you are applying, brake, but the cycle stops. Okay, so it stops at a certain point because of friction and also the brake as well. So that is a negative work. So remember that work can be positive or can be negative. Now, unit of work is actually joule. Okay, joule, it is measured in joule. So when the work done is said to be 1 joule, when 1 Newton of force is applied to one and the displacement would be 1 meter, then we can say 1 joule work has been done. Okay, so work done is equals to energy transferred, that how much energy is being transferred, okay, to something else, right? Now, everyday example of work we see, if we see, okay. So pushing a shopping cart, that is a positive work, right? Kicking a football, again, most probably a positive work. Force transfer to the ball here, okay. And then ball starts moving. It gets displayed. Lifting weights. Force against gravity creates upward displacement. Okay, so gravity is pulling something down and you are putting it up. So this will be a negative, yeah, work done. And drawing water from a well. So force upwards creates upward displacement. Okay, so that's why, because you are putting force upward towards upward and bucket will come out. Okay, the bucket will come out. Okay, so you can think more examples, right? Like this, and just let me know in the comment like what more examples you can think of. Okay, now let's talk about how does it, it really work. Let's analyze it. So if you're sitting on a desk, okay, so force is there. Yes, because if you're sitting on your desk, let's say here, so gravity is, pulling you down. Okay, so that is there. Displacement is there? No. So no work done, because work done is equals to force into displacement. Now displacement is 0 and force could be something, right? Here 9.8, let's say. So if you multiply something with 0, you will get 0, right? So if displacement is ever 0, there is no displacement, always you can, ultimately come to a conclusion that work done is 0. Walking with a backpack. So force is there. Yes. Upward force holding the backpack. You are holding it upward. And displacement, yes, but horizontal. So even if you are holding your backpack, like for example, you are walking like this and you are holding your backpack here, up in upward direction, let's say. Okay, and you are walking. So what happens? Let's say you are walking in this direction. Okay, that's very bad. Okay, right? So what happens? You're walking in this direction, horizontal direction, but you're holding your force, the force is upward. So this is 90 degree, and I told you that cos 0 degree is equals to 1 and cos 90 degrees is equals to 0. So when you will apply the formula W is equals to FD cos 90 degrees, you will get it as F into D, okay, into, you can say 0, right? So everything will come out as 0. So again, here also no work done. Then climbing stairs. So force applied, yes, It is applied pushing against the gravity. Displacement, yes, it is there. So work done would be, an angle is 0, right? You are going upward and force is also applied upwards. So you will say that here the work done is there. Now let's do a little bit of calculation here. Okay, so a force of 20 Newton. Okay, let me just annotate. Yeah, force of 20 Newton is there. Okay, moves an object 5 meters in the direction of the force. This statement is important. That is how you will calculate the value of cos theta. How much cos theta is going to be there. So a force has 20 Newton of, force is there and moves an object 5 meters in the direction. So in this direction only. So displacement is 5 meter and cos theta would be 0 because angle is 0. No angle, right? 0. Okay, so here you will put the values. So W is equals to 20 into 5 meters into cos theta, that is 1. And you will get it as, if you'll multiply it, 100 joule work done is, done by this object. Okay, so you can calculate it like this. Now let's do some questions. Okay, so work is done only when you can select, multiple option. Force is applied only. Objects get displaced only. Both force and displacement occur in the same direction. Okay. Second question is, a boy pushes against a wall with a force of 50 Newton, but wall did not move. No displacement. So the work done is 50 joules, 0 joules, or cannot be determined. Okay. Last is, in which case is the most work done? 10 Newton force moving object 5 meter at 0 degrees angle. 20 Newton force moving object 3 meters at 60 degree angle. So you have to find the cos 60 degree value. Okay. And 30 Newton force moving object 2 meters at 45 degree angle. So if you know the value of the angles, you will be able to find it. You can quickly check it, or you can ask me also in the comment section if you do not know the values. Okay. So thank you so much for joining the session. We have learned about the definition of the work. We talked about what conditions are there. We talked about positive and negative work as well. Also, we came to the formula that how, work can be calculated and unit of work. So now your work is to do all those quiz questions, right? Answer me, and also find 5 examples at home where the work is being done. Okay. So thank you so much for joining. Take care. Bye-bye.